We're going to go ahead and start talking about it. We're going to fill in each of the terms for each of the definitions. This is just so we can have a nice little bank of understanding because, we've been doing kind of the same thing all year so far, and this is a little bit different. So I want to make sure we all understand what all these words mean. So the first definition we have is a function that changes the position or orientation of a figure. This is our umbrella term that we talked about yesterday. A transformation, but we're not just going to call it any type of transformation. This is a rigid transformation. Okay? And what rigid means is that it doesn't change the size. Yesterday we talked about... Can you guys not do that, please? Yesterday we talked about these three different types, right? Translation, reflection, and rotation. And as we saw in the Alex assignment, none of those three change how big or small a shape is, right? So rigid basically just means we keep it the same size. That's all it means. Now there is one type of transformation that changes the size, our fourth type. We're going to talk about that in the next unit later on. Okay? So when I have a transformation, right, any of these types, I have a starting point like we saw. We had shape A going to shape B. So shape A is my starting point. That's going to be called the pre-image. Pre-image. You can think of it like the before picture. You guys ever seen like a before and after picture of someone who either like lost a bunch of weight or, I don't know, got a nose job or something, and they put the before picture next to the after picture? Yeah. The pre-image is the before. Pre-school is before school, right? A pre-test is taken before the test. So what does the prefix pre mean? Before, right? So it's the image beforehand, the before picture, where a figure is originally located. So it's my pre-image is right here, right there, and right there. It's where we start, right? My before. So what do you think are we going to call the after picture? If my pre-image goes before, you would think post-image, right?
After image.
After image, another great guess. We're just going to call it the image. I know, it's a little weird. So the pre-image comes before the image, right? So like I said, if you have like a before and after some weight loss or something, the image is the after. It's where a figure ends up on a graph after we do some type of transformation. So if we look at what we wrote down yesterday, my pre-image got translated or slid over. There's my image, right? My before and my after. For reflection, my pre-image was right here. We flipped it over that line. There's my image, the after. And for a rotation, I have my little division sign here. That's my pre-image before. I rotated it. And now there's my image, the after. Give me a thumbs up if that's making a little bit of sense so far. Pre-image, image. I know it's tempting to say post-image. We're just going to call it image, all right? Now, after we transform something, and this is what we're going to get into today. Yesterday I mentioned a little bit more of the specifics. We're going to have to write our image in something called prime notation. Prime notation. Okay, and it's just a little apostrophe on top of a point. It shows that it's part of the image. You guys, in elementary school, you guys learn about trees, right? Where if you cut down a tree, what do you see on the inside of the tree? Rings. What do the rings inside of a tree mean? How old it is, right? So if there's like 10 rings, how old is the tree?
10 years old.
10 years old, right? We want to think about these apostrophes in the same way. So if I had, for example, point A, right? Let's just say I've got point A somewhere and I translated it over. That turns into A prime. Everybody say A prime.
A prime.
Ooh, that wasn't everybody. Everybody say A prime.
A prime.
Okay? So my pre-image A turns into A prime. What if we took A prime and we transformed it again? What do you think we would call it then?
A prime.
A prime prime. Good. Or A double prime. So each little apostrophe is like each ring on a tree trunk. It signifies 1 year that tree's been alive, or it signifies one transformation that we applied to that point, right? A to A prime to A double prime. If we did another one, it would be A triple prime or prime prime prime. Yeah, it's probably easier to say double prime and triple prime, especially with where we're going to go when we do like 4 or 5 transformations at once. We don't want to say prime 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 prime. That would be annoying. All right. So we'll see that in action today. We're not going to worry too much about it right now. Now this is a word that hopefully you guys have heard before. It's a term used to describe 2 or more figures that have the same exact size and the same exact shape. Does anyone have any idea of what that word might be? Diego? Reflection. You're not wrong. A reflection does have the same size and shape. I love that you remember that from yesterday. Even like outside of this transformation stuff. If I have 2 shapes that are exactly the same, you guys know what we would call those 2 shapes? Symmetrical's good. It starts with a C. Does that help? Copy. I like that. It's called congruent. Give me a thumbs up if you've ever heard that term before. Congruent. Okay, a couple of us have. That's good. Congruent just means same size, same shape. Right? So all these transformations that we're going to talk about, they all result in congruent shapes because we're not shrinking it and we're not expanding it. Like you saw on the Alex assignment, anytime you saw a little triangle with a big triangle, that was none of the 3 transformations we talked about. Same size, same shape. Everybody say congruent. Congruent. Everybody say congruent for me real quick. Congruent. Good, just so we can get used to weird kind of word like that. All right, congruent. So that's all the new stuff. Not too bad, right? Maybe it is. Hopefully it's not. Now this is what we talked about yesterday. A transformation that slides. What do we call a transformation that slides?
Translation.
A translation, right? Anyone remember how we can kind of remember what a translation is? Languages, right? What about languages, Alyssa?
English or Spanish.
English or Spanish, okay. What were we going to say? Yeah, if you're sliding in between languages, you're translating those words. Now, they're the same words, right? They mean the same thing. They're just said in a different language. Like we said yesterday, if you have a parent or someone at home that speaks another language, sometimes they'll speak English, they'll slide into Spanish, they'll slide back into English. That's kind of how we can remember a translation, right? We got 4 directions, left, right, up, or down. As you can see over here, our example, we did right and down. It doesn't have to be a left and right and an up or down. It could just be right, it could just be up. This is what we're going to focus on today, is a translation. All right? Now, what type of transformation did we say yesterday is like a flip?
Rotation.
Close.
Rotation.
Still close. Reflection, right? Yeah. I know, I heard you. Reflection. Right? What do we think of when we hear the term reflection?
Mirror.
We think of a mirror, right? If I look in the mirror, right, does my image change at all? Do I get bigger when I look in the mirror? No, the size is exactly the same. It's just inverted or flipped around. So we always want to think about a mirror when it comes to reflections, which again, something we all have familiarity with. I assume we all have some sort of mirror or reflective surface at home, right? Windows, you see a reflection. Like a lake, if you look down, you see a reflection, kind of like that poster up there. Question? Sure. All right, now with reflections, we see this little dotted line, right, going down the middle. That's like our mirror. If this is me, we talked about like Phineas yesterday with his triangle head. He's looking in the mirror. It's the same thing, just flipped around, right? So that little dotted line is called the line of reflection. The line of reflection. Now, in 8th grade, we're going to keep it nice and simple. We're only going to be reflecting over the x-axis or the y-axis. Right? So it's either going to be flipping over this y-axis or it would be something flipping down over the x-axis. We're going to get more into that next week when we talk about reflections. But again, just kind of recapping what we introduced yesterday. And then our last transformation, our last rigid transformation is a turn. Which one did we call a turn?
Rotation.
Rotation, right? A rotation. I just realized I messed up the colors on what's on the board, but that's okay.
Mr. Church.
Yeah.
So the last one will be line of rotation.
Very good assumption. We'll get to that in just a second. You're very close. Okay. If I'm rotating, what do we think about? Do you remember the analogy we used yesterday with rotations? Turning a car, a steering wheel, right? If I'm rotating my steering wheel, is my steering wheel shrinking?
Yeah.
Is it getting larger?
Yeah.
No, it's staying the same size, right? Again, that's what we mean when we say rigid. It's not changing its size at all. But we are changing its orientation. We're turning it to the left, we're turning it to the right. Okay? Now, the point that we're turning a shape across, and this is a little bit more advanced that we'll get to much later on, is called the center of rotation. Because we're not going to be rotating shapes along a line, we're going to be rotating them across, or I guess, around a point. And for us, again, we're going to keep it nice and simple in 8th grade. We're just going to be rotating around the origin. Where's the origin at on a graph? In the middle at 0, 0, right? Great job. So let's add that in, 0, 0. And we'll have a good little visual example of that once we get to it, probably at the end of next week. So we're going to keep it nice and simple today. We're just going to be talking about this one right here, translation, also known as a what? A slide. That's right. So as you're finishing up that last one, I'm going to get the second piece passed around. Go ahead and glue this in after what we took yesterday, or wherever you have space. It might be right after this. Matthew? Oh,
I didn't get
you didn't get it?
Oh, I remember.
I thought I knew this, yeah. Did I do this one? I did. You're awesome, Mr. Church. Oh, thanks. I appreciate it. Here's your heading. We're going to do the table of contents too. Whoops. Let's go back to that. So this was 10:14, this was 10:16, today is 10:17. Okay, here's our heading, same as the table of contents, obviously. Give me a thumbs up if you feel confident in your ability to count. Anybody feel like they're pretty good at counting? No? You don't feel confident at counting? Okay. We'll work on that, I guess. But just like we talked about with slope, if you know how to count, you're going to know how to do this. It's very, very simple. So let's get started. Triangle ABC here. Why do you think we call this triangle ABC? Because there's 3 points. What are the names of the 3 points, Leon? A, B, and C, right? Nice and easy. If I see points A, B, and C, I'm going to call that triangle ABC. Okay? Now, let's figure out first where my coordinates are for A, B, and C. Can I get a volunteer to help me out with what my coordinates are for point A? Yeah, Jawad.
-4, 3.
-4, comma, 3. Perfect. Thank you, Juwan. Can I get a volunteer to help me out with my coordinates for B? Yeah, Julian.
-3, 1.
-3, 1. Good. This is why we did all that practice on Monday and Tuesday with our coordinates, so that we could do this nice and quick. Last but not least, who can help me out with point C? Ryan, go for it. -1, comma 2. All right. So that's where we're starting at. If this is my before picture, what can I call this triangle right here? The pre-image. Exactly. Right here is my pre-image. And we're going to graph the image. We're going to graph the image, or the after, of triangle ABC after we translate it 5 units to the right and 6 units down. 5 units to the right and 6 units down. So those are my directions. Those are my distances. That's all I'm going to have to do is count 5 units to the right and 6 units down. But we're going to do it 3 times because I have 3 points. So I'm going to start with point A. Okay? Everybody go and put your pencils right there on point A for me. I'm going to keep the colors right. Okay, from point A, we're going to count 5 units right. Okay, here we go. 1, 2, 3, 4, 5 units right. What are we going to count from there?
3 units down.
6 units down. Okay, it's always going to give you where to go. 6 units down. 1, 2, 3, 4, 5, 6. In that new spot, I'm going to make a point. And what am I going to call this image point now? A what? A prime. Exactly. It's like rings on a tree. I put one little notch up on my A to signify that I've transformed it one little time. Where are A prime's coordinates now? Who can help me out with what are A prime's coordinates? Eli?
-3. No, it's 1, -3.
1, -3. Perfect. Exactly right. 1, comma, -3. We're 33% of the way there. Now we're going to jump over to point B. But before we do, how does that sound so far? Thumbs up if you're like, okay, I get it. I read where to go and I count it. Thumbs sideways if you're like, it's still a little bit weird. Okay. For point B, where am I going to count first? What does it say to do?
Right 5.
Right 5. Okay. 1, 2, 3, 4, 5. And then Eli, you said what?
6 down.
6 down. 1, 2, 3, 4, 5, 6. Boom. What am I going to call this point?
Prime B.
B prime. Right? Looks like a little 1, but it's actually an apostrophe. B prime. Who can help me out? What are B prime's coordinates? Yeah, Ray.
2, -5.
2, good. 2, -5. Exactly right. 2, -5. And finally, we'll go to point C. Where am I going to translate point C? 5 units to the right. 1, 2, 3, 4, 5. And then what? 6 units down. 1, 2, 3, 4, 5, 6. I'm going to make a new dot right there. And what am I going to call that new dot? C prime. What are my coordinates for C prime? 4, -4. Good. 4, -4. So now I've got A prime, B prime, C prime. I'm going to connect all those dots together to make my new triangle. And it looks exactly like what we have up here, right? Just a little bit more specific because we actually have measurements now. We took it right, we brought it down. Did we turn the triangle at all?
No.
No. Did we flip it at all so it's backwards? No. We just slid it over and we slid it down. Do these two triangles look like they're exactly the same shape?
Yeah.
Yeah. Are they exactly the same size?
No.
Yeah, they are.
Oh my
Because look, from A to B is down 2 over 1. From A prime to B prime is down 2 over 1. From B to C is over 2 up 1. B prime to C prime is over 2 up 1. So it's the exact same triangle. We just moved it point by point by point. So what?
In the coordinates for C prime is wrong because it's supposed to be positive.
Oh, you're right. You're right. You're right. Good catch. Yeah, this should be positive 4. Negative 4. Great catch. Yeah, positive 4, negative 4. Thank you, Jawad. So these two triangles are congruent. What does it mean for them to be congruent again?
Same
They're
size.
the same size and the same
Shape.
shape. Right? They're congruent. We didn't turn it. We didn't flip it. We just slid it over and slid it down. Okay, that's a translation right there. Has anybody ever moved houses before? Yeah, I've moved a bunch of times. Now, when you're moving, if you have like a bed frame, can you just pick up the bed frame and put it through the door and then put it in the car?
No, I do need like,
Most of the time not, right? What do you have to do to the bed frame? Take it apart, put it in the car, take it to the new place, and then do what? Put it back together. Is it the same bed? It's the same size, right? It's exactly what we're doing here. We're taking our bed from our original house and we're breaking it apart. Each little dot is going on its own journey, right? It's the same distance because they're all going to the same place. And then we're putting that bed back together in the new house, in the new location. That's the way that I always like to think about it. Hopefully that kind of helps you visualize what we're doing here. So, do me a favor. Go ahead and flip over to your vocab chart for a second. Some of you already have it open. Everyone should be looking at their vocab chart real quick. And we're going to fill in some blanks here. So the first one, triangle ABC, is the blank of triangle A prime, B prime, C prime in the transformation above. Anyone know what might go in this blank right here? Translation. Close. Dylan, you said it. Is the pre-image. The pre-image. So ABC is the pre-image of A prime, B prime, C prime in the transformation above, which is called a blank because of the way the figure slides along the coordinate plane in a straight line. Who could help me with this blank right here? Yeah, Anila? Translation. Translation. Because we're sliding it to the right and we're sliding it down. Without changing the triangles, I don't know what's supposed to go in that blank there. I would think size, yeah, but size wasn't a vocab word. I don't know why it would do that. Prime notation? No, without changing the triangles. I guess, yeah, it would be shape and size. But that's the, anyway, I don't know. We're just going to write shape and size. Yeah, congruent would be this next one right here. Because both triangles are the same size, we can conclude that these two triangles are congruent. So I don't know what I was thinking there. I must have been tired when I made this, but that's okay. Without changing the shape and the size. Two more. Triangle A prime, B prime, C prime is written in blank. Anyone got that one? Yeah, Sophie?
I was just saying this
Oh, sure. What kind of style is A prime, B prime, C prime written in from our vocab chart? English, yeah. Rigid transformation, good guess. I got all these little apostrophes, right? Prime notation. Good. Thank you, Alyssa. Prime notation. So because A prime, B prime, C prime is written in prime notation, we know that this triangle is the blank of triangle ABC? What's that last blank going to be, you think? If ABC is the pre-image,
B image.
exactly. A prime, B prime, C prime is written in prime notation, so we know that this is the image or the after of triangle ABC. All right, just a little summary there on what we're talking about. So take 2 minutes. See if you can get this example done on your own. DEF, you're translating it 4 units left, 3 units down. Take about 2 minutes. I'm going to try and see what's supposed to go in that blank real quick. You're already done. That was so quick. Is this one worse?
What was that?
That looks good, Gianni. So start by figuring out what these coordinates are, and then you're going to move each of them, and you're going to figure out what the new coordinates are. That's okay. There should be an eraser in your box.
Attention Edward Harris Middle School, we are experiencing an earthquake right now. Please take cover. Drop to the floor. Cover your head. Please get
Okay, just
Is this an actual earthquake?
no, it's a drill.